Is this thing on? Good. All right. Hello, Internet. Today we are going to be playing with our ripple shader. But first, welcome back. It's been like 2 months. So I moved, and everything's different. So I don't really know how this is going to turn out. I don't have the audio fully calibrated, the video fully calibrated, and everything's just new. So bear with me. Might take me a bit to get this all sorted out. I think it's good, but it's hard to tell without just kind of doing one of these. And instead of just testing, I'm going to test in production, because that's how you're supposed to do this. Anyway, we're going back to the ripple shader because I want to go back to the ripple shader. And so this is sort of where we're at right now. It just sends out a single pulse from a specific point in world space that can kind of hit a whole bunch of objects and look like this. And so you get this really cool, like, sonar-y effect. And that's sort of where we're headed with this. So what I want to do is I have this little scene here, and I want to update this so that I can click anywhere in this world and spawn one of these ripples. Initially, we're going to run into some problems, and we won't cover those here. But that's sort of what we're going to try to do. So this shouldn't be too difficult. I think this should be a relatively straightforward thing to build. And so the basic idea is we have this world space ripple material right here. And that has a ripple origin, which has a X, Y, and Z. And so that's sort of the position of where you dropped it. And then there's this other component, which is W. I think we're going to translate W into time between 0 and 1. And so the general idea is you get a position and you get a time, and then we can just update that time over time. and then it will produce the effect, which means we're actually going to get rid of this ripple repeater script that we wrote previously, which just automatically increments the distance and kind of wraps it around. We don't need to do that anymore because we can actually just put it embedded in the time and then have the ripple distance and a separate thing measure everything. So the ripple distance can actually be translated, multiplied by the W to get the full width. At least that's the idea. So we're going to try that. And my computer's being a little bit weird. This is Visual Studio. This blank icon right next to all the other blank icons. This happened right when I clicked record and I just said okay. But Windows is trying to throw me for a loop. But there we go. This is our shader. And so what we need is this ripple origin and this ripple distance. And we might want to... We'll ignore all of that for now. It doesn't make sense to do all of that. Ripple distance is going to be multiplied. That's not right. By our ripple origin.w. And that should be it, right? It's been a while since I've looked at this, but what we're doing is taking the ripple distance and multiplying it by this, which means we're modulating our distance by a specific value of w here, which is the fourth component of our vector. So that should allow us to scale this. I'm going to add a space there because that's bugging me. And then, yeah, we should be done. Unity? Nope. Hold on. Okay, that's working less well than I had hoped. Turns out that icons are useful. So now that we have W, I should be able to increase this, and it will go out to, let's set this to like 5, so it makes a little bit more sense. So this should be about a ring with a radius of 5 in our world. And so now honestly, that's pretty much it. But I want to do one more thing, and that is to change the transparency of all of this. So we have this ring strength variable, which is actually changing the color that we're actually emitting. Yeah, we actually multiply that by the emission as well. But I want to actually plug in a scale here, which is just going to be 1 minus our ripple origin.w. which means it's going to just have a exponential or a linear fall off. So as it gets further away, it's going to get dimmer and dimmer and dimmer. That's W equal to 0 or 1. And then as I come in, it should fade in. And you kind of get the idea. As it goes out, fades out. And then when we get negative, we actually start subtracting and we get this really weird dark red thing. That's not ideal, but I don't really care about that because that shouldn't actually ever happen. When this increases up to 1, we'll just delete it. Like effectively, once this gets to 1, we can just clamp that, and it's not actually going to draw anything because 1 minus 1 is 0. So the entire glow is just negated. It doesn't exist anymore. So let's change this a little bit more. Do I want to do that? No, let's not do that. Let's delete these. And then let's add an ability. So like this is how we were doing the animation previously. We're changing the ripple distance and kind of had this modulus, so it would kind of wrap. I don't want to do that anymore. Instead, we are going to have 2 components. I think 2 components is the best way to do this. One to increment this, this W value on the vector, and another one to change the X, Y, and Z. I think that makes the most sense, but I haven't done this, so I don't know what the best way to do this is. But what I'm thinking is this way we have something that tracks the time and something that assigns the state. So we have like a state thing that is going to know where it is, but also increment the time over time. But then we also need something that where we click, it actually figures out I need to create a new ripple here. And so those feel like 2 different things to me right now. So that's sort of how I'm going to design it. And if it doesn't work, I mean, it'll work. It just may not be elegant. Then we can change it later. So let's create a ripple. I don't know a good name for this. Incrementer. That's not the name we're going to use. I'm going to create a separate class. Call it the ripple state, because that or not. Okay, computer's freezing. Cool. Everything's going so well. Ripple state. That'll show up eventually. There we go. And we can delete these other 2 because I don't need them. Delete. And delete. And so the ripple state is just going to increment W up to 1. So we can actually rely on a lot of this. So I'm just going to copy and paste the entire ripple repeater over here, like so. So here's our max value. We don't need that. Here is our speed. We'll use that. And then we don't need any of this. So distance. This is calculated. This was calculating the distance. We don't want to do that anymore. We want to do a time. Time, I guess, makes sense. So time is actually going to be equal to our. So the reason I'm hesitating here is because there's 2 ways we could do this. We could do a material.get float of our ripple origin. That'd be a vector, actually. We'd get our origin back out, like so, and then do .w. So this would be our origin equals this, var origin time is equal to that. And then we could just add that, like so. And we could do this, and then at the end, set our origin or our time equal to this, like something like this. Kind of just riffing on ideas here, because I don't know if I like this idea. The problem with this is this way we actually need to go and actually get that vector every single time. And I'm not sure that makes sense, because at least in this implementation, when we're just clicking, if you click, we don't need to, once it gets all the way up to 1, we don't need to do any more updates. So there doesn't need to be all this back and forth between you and the shader. That doesn't need to happen. And if we implement it like this, we're kind of stuck with that. We don't have a way around it. So I'm kind of leaning towards doing a private vector 4. And this is just going to be our ripple origin. And we can expose this with a setter later so that you can actually set this with our other, our raycaster or pointer, or whatever we're going to call it. This can get set that way. And then we don't need any of this. That can just go away. And we'll initialize this to like a vector 4 dot 1. So this doesn't actually matter what it is. The reason I'm setting it to vector 4.1 is we want our W to be 1. It doesn't matter what anything else is, but as long as W is equal to 1, it's going to be transparent. And so that's why that's happening. We could set it to anything as long as W is 1, because the position doesn't matter if it's transparent. So take this, and then ripple.origin.w, increment it like that, and we're going to set it back. So the ripple origin.w is equal to the ripple origin.w plus this time times the speed. We're going to add a clamp here, which is just going to be the minimum value between that and 1. So if it exceeds 1, then we're done. And we aren't going to actually change it anymore. We're just going to stick there. And then set float. We don't want set float. We want set vector of ripple origin equal to our ripple origin. Ta-da! And just to prove that this is working, we can set this to 0 instead, which means it will do 1 pulse and then stop. And it'll be at the 0 point. Theoretically. All very theoretical. Because it's been a while. This is my first time picking up Unity since 2 months ago. So yeah. Sorry if it seems a little bit rusty. That's because it is. But we'll figure it out. And this feels like a good project to kind of explore a bunch of things, because it's something that I just kind of want to explore myself. So I'm going to set the speed to slow. So 0.1, so it means it's going to take 10 seconds for it to fully expand. That should give us enough time to actually kind of see that things are working. And we should be able to select this world space ripple and actually watch it count up. Assuming I did it all. Well, that was really fast. We got 1 pulse. That's good. Why was it so fast? Did I do something silly? No, that's not it. Ripple origin.w plus our time. Oh, time.time. That's why. I used the full time instead of just the delta time. This should make it increment a little bit more logically. And so hopefully get this nice. Why is it repeating? What? Hold on. Why did that happen? Sorry, I didn't understand that at all. Okay. We have to refresh this. Is it repeating every 10th of a second? That doesn't make any sense to me. Hold on. What have I screwed up? Right? It's got to be something that I've done, because there's nothing that would force that to happen otherwise, to my knowledge. So we have this, our ripple distance times the ripple origin.w. That seems to make perfect sense. That seems to make sense. Is our ripple repeater on? Wouldn't that be funny? Let's see. How can we test that? Yep. Okay. We'll turn that off, and that behavior should go away now. We shouldn't see it pulse that way and then shrink, and then I think that was because we were modifying the distance. Yeah. So there's a single slow pulse. We can make this faster though, because it works now. So if I put it at 2, it should take half a second now. It should be really fast. Just go, yeah, cool. So that works. And the cool thing is, just to prove that this is actually doing what we want it to do, and well, actually no. One of the issues with doing it this way, I was going to change W back to 0. That won't work because W is not stored. This is not a stateful variable. If I change it here, it's not going to matter because we're resetting that in our script here. So this ripple origin is the one that actually matters, and it's the one that we need to change if we want it to put it in a different spot. So let's create a vector for ripple origin, and I'm going to create a setter here, which is going to do ripple origin equals value I'm actually going to do something weird. I'm going to make this a vector 3, which means our ripple origin is going to equal a new vector 4 of value.x, value.y, value.z, and 0. Which is, I don't know if this is actually a good idea, but it seems like a good idea. So we're going to try it. And so this is going to take a vector 3 and convert it into a vector 4 with a w value of 0, which means we can just take positions in our game world and send them to this thing, and it will make them into logically making sense ripple points, because this means it's the initial first step of that ripple. So now with that, I should be able to actually implement something that can actually send these points to this. And so let's just create a ripple spawner. And this is just going to do raycasts from the camera and spawn things where it hits. So ripple spawner. And so ripple spawner is, we've done a bunch of these before. Actually, I think we've done something pretty much identical to this in the past with like a grass where we needed to drop objects onto the grass. This is going to be pretty much that, just in this. So if our input get mouse button down 0, so if you press the left mouse button, this is mostly for debugging because the game mechanic I want to build doesn't actually use this input. So this is more just so we can actually start putting these things in the world, and then we can experiment more. We will also need a copy of our ripple state. So we have the state, and then when we press our mouse button, we are going to raycast towards our mouse point, hit something, assuming we hit something, and if we do, then we're going to spawn something at that point in our state. So we need to do a raycast. Ray equals new ray. This isn't how this works. We need a camera object, so camera main ray screen point to ray, and we want to take the mouse position. So what this is going to do is take a position on our screen and translate it into a ray. So it's actually going to use the camera's view matrix to turn our little screen position into something that we can actually project into 3D space, which means we should be able to get this nice ray And then we will want a raycast hit equals ray hit. There we go. And then if physics.raycast our ray out hit. I think this is right. Again, it's been a while, but there we go. So we should cast our ray, and we'll hit something. If we hit something, this raycast is going to return true, which means our hit is going to have that details inside of it. And then we can do some other fun stuff with that. So specifically, I want to take this hit and get the position. So we want to do state.ripple origin equals hit.point. And so when we click and hit something, we are going to override the position of our ripple with this. There's a pretty significant issue with this, but I'm just going to see if it works. And if it does, then we can see the other issue. So there's our first pulse. And I never attached the object, so that's never going to work. So let's actually do this the correct way. Assign our ripple state. There we go. And we should be able to run this. And now we should be able to click and see all these fun things. Like that. Let's slow this down just a bit because that's a bit fast. Cool. So now we can kind of click and send out these nice pulses. The problem is we can only send out one of them. So if I do this, the previous one disappears. And that's a problem with our implementation. We've actually solved this before with our shield shader, which I'll probably link at the end of the video and probably in the description too. But the entire point of that project was to bring about creating these fun new sending arrays, I guess, of points to a shader. And that's what we need to do here. We're not going to do that in this video because this is already going on a bit long. And this is a relatively straightforward thing. But that's the next step. Because once we can send an array of these things, then I can click all over and get multiple pulses, I guess. And they can even interact with one another and do all sorts of other fun things. We're not to that point yet, but that's hopefully where we're going to end up. But yeah, I think I'll leave this here because this is sort of where I wanted to get, where we can just spawn these things. And it kind of highlights the issue of we need to be able to send arrays to this because right now we can't. So that's next, and I will see you guys in the next video. Hopefully there's going to be more stuff coming a lot more frequently. Kind of got held up a bit with moving and everything, but that seems to have all been kind of resolved now, besides the desks that are still wrapped behind me and the boxes that you can't see out of frame. But ignoring those, we can actually get to doing fun stuff. So we'll do that. Yeah, I don't know. Until next time, see you, Internet.